Okay, it is 10:33. Couple minutes after. Getting started. My name is Michael Johnson. I am Assistant Advanced Materials Technology Engineer here at MnDOT. And I will be moderating the Intelligent Construction Technology Team Topics session here. We're going to get started with Amanda Gilliland. She's a senior engineer with the Transtec group, a Terracon company, and she's going to be talking about the overview of ICT technologies in the state of practice. Please welcome them.
Hey, good morning, everyone. I'm excited to be here. I'm going to spend maybe about 12 minutes here. And I'm just going to be introducing some of the technologies that we're going to talk about during this session. So just want to make sure people have enough information to follow some of the speakers after me. So you'll be getting perspectives from agency, contractor, and the manufacturers. So again, I'm going to just really briefly introduce all the technologies we're going to be talking about, talk a little bit about some of the standards and national guidance that exists. I'm also going to introduce beta, which we've heard about already today, but we'll just kind of make sure everyone knows what that is, and then talk briefly about some improvements in the future. So these are the technologies that we're kind of focusing on this morning. So the first one is going to be automated machine guidance, or AMG. So this is where we are building surface models for our construction equipment. And I'm going to kind of highlight a milling example. Then we'll talk about the MDMS, which is the Material Delivery Management System. This includes e-ticketing. And then we'll talk about intelligent compaction, paver-mounted thermal profiling, and dielectric profiling systems. So starting out with AMG, again, this is where we are collecting surface data from our existing surface. And we are then taking that and building a model of what we want to construct. And then we are uploading that model to our construction equipment. So it could be a grader, a dozer, whatever. I'm showing a mill here. But so the idea is, rather than saying, okay, I'm going to go mill 2 inches off my pavement and then pave it back, we can make all of the corrections needed to really make a nice, smooth surface. So some areas we might need to mill 1 inch, some areas maybe 2, and we can tell the equipment that and really improve our ride. So what's really cool about this equipment is we have the technology to really, really quickly be able to get that information from the surface. So where traditionally we may have had to send a surveying team out to do cross sections across the pavement, we can actually use LiDAR-based equipment to really quickly get that surface information. So we get a really dense point cloud with this LiDAR data. It's really safe. We can drive at traffic speed in live traffic with it, which is really, really huge. So we can get all of our information really quickly with this LiDAR equipment. And then we can build our model with that. And then we also have the ability, since we have such a dense amount of data here, we can get, traditionally, when we do any sort of like model on equipment, we'd have to use pretty sophisticated GPS equipment to be able to get that really controlled elevation data. But because we have this nice new dense model, we can use the sensors that are on our equipment to get us that elevation. So we're just telling the machine, okay, here's what the surface is now, here's where we want it to be, and it's able to do that without needing that really, really sophisticated, millimeter GPS or robotic stations. Another thing you can do when you're building your model, we've got these really great platforms to be able to build models. You can kind of optimize smoothness, you can optimize your cross sections, because again, we've got that dense amount of surface data where you can go in and really kind of optimize your model. You could also tie in GPR. If you've got GPR information and pavement thickness, you now have, an idea of how much you can mill, how deep can you go with the mill, make sure that you, have enough pavement there to do the milling you want to do. So, really, really good, great for optimizing all of the cross sections and, smoothness of your roads. Okay, we've got our MDMS. So this is all about, material delivery. So this includes your e-ticket. So I know that e-ticketing is really taken off across the nation. So this is a standard that's going to take that e-ticket and make it kind of universal across the board there. So this is also, anything that you usually are collecting with your material delivery. So if you're doing any sort of like testing or inspection on site, taking that, this can all go into the MDMS. Okay, we've got intelligent compaction. I feel like everyone's probably pretty familiar with what this is. So this is taking, if you're using it for like a soils project or foundation information, you've got an accelerometer mounted on your vibratory drum. You're able to measure the response of whatever you're sending into the ground. So as it gets stiffer, that response is changing. So you're able to get like a nice map of stiffness information. Everything I'm talking about today is geospatial, so we've got our GPS tied to all of it. For asphalt, we're able to also monitor our compaction temperatures, which of course is really important when you're talking about asphalt quality. So we're also going to be talking about paver-mounted thermal profiling. This is where you're equipping your paver with a temperature, infrared temperature sensors or a temperature measuring device. And you're able to get really, really detailed temperature information behind your paver screed. Again, temperature is one of the most important things when it comes to getting good compaction on your asphalt, which is really, really important for quality. So now we're able to get a very detailed temperature map that we can use to determine, things like segregation and other issues like that. Okay, we're going to talk about the dielectric profiling systems. So this is the kind of traditional cart mounted system. We'll also talk about the roller mounted systems. Those are a little bit more recent. So this is a great quality tool. Again, compaction density is so critical when we're talking about asphalt quality. So this is going to give us the dielectric, which correlates very, very well to density. So we can create these heat maps that are showing density across the project, which just gives us way, way more information than just taking like a gauge out and doing spot testing. So again, we're going to talk a little bit about, the cart or vehicle mounted versions, and then also the latest roller mounted versions. Really important to get into kind of the standards and everything. George talked this morning about, all of these standards that have been created over the past decades. And that's really important because that has kind of like set us up for success in a way that we can, keep building into these platforms that we've created to just keep improving our quality on our construction projects. But I did want to show this graphic. So on the x-axis here, we're showing maturity, okay? So I've got all of the equipment plotted here, and we're growing in maturity on that x-axis. So kind of starting with research level and then going into like a proven operational standard. And then on the y-axis, we're starting, this is going to be for adoption. So we're starting at the bottom where it says not commonly used and then kind of growing into broad adoption. So we've got all of our technologies I just introduced on here, and you can just kind of get a feel for where all of them are at. So, the most mature are probably going to be the IC and the PMTP. We've got those AASHTO standards. They've been around for a while. We've got other AASHTO standards for things like MDMS and DPS. Those still might be a little bit in the validation. So maybe there's still some changes or studies being done to kind of optimize those standards. And then we've got things like the roller mounted DPS, which is kind of still in that pilot phase, but moving quickly. And so this isn't perfect. There's probably some wiggle room on all of these. But generally from kind of like a national standpoint, this is kind of where they fall. Okay, there's AASHTO standards for these technologies. So these two I'm showing here are going to be kind of like global standards that are going to apply to all of the intelligent construction technologies. So these ones are really important. They've been around for a while. That first one, MP39, is the standard data format. So if you have geospatial quality construction data and you're following the standard, that means it's going to be compatible with data and with some of the other technologies that we're already using. And then the PP 114 is really important too. This is really big into data management and how we can usefully section out this kind of information into a way that makes sense for us, sectioning things out to lots and sublots and things like that we're used to doing on our projects. And then we've got the individual standard specifications as well. So of course, we've got DPS up here, thermal profiling, intelligent compaction, and MDMS. So we've got those global standards, and then we've got the individual standards for the technologies. So George, of course, mentioned Beta this morning. So what is Beta? So we've got all these technologies and all these standards, and Beta is compatible with all of it. So this is a tool that's available where you can say, I can bring in my intelligent compaction data and my paver mounted thermal profiling data and my DPS and my MDMS, and I have one platform where I can look at all of it together. And that is really, really critical because it can be really difficult to try to make sense of all this information if you're having to use, 4 different software programs to do it. So Beta, one standardized platform for viewing the ICT data. It's compatible with all those standards I showed you, and it's just the power tool for viewing this geospatial construction data. And so here's just one example I'm going to show. And again, the point I want to make here is if I was having to use, PMTP software for this and IC software for this and DPS, it'd be a lot harder to make a chart like this that's just really quickly showing all this information. So starting on the left here, we've got our PMTP. So that's our paver mounted temperature system. That's going to give us that nice heat map of our temperature right behind the screen. We're moving to IC data. I have pass count information shown. So we're able to see, okay, here's my temperatures behind the paver. Here's how many passes my roller's making. You can also go look at the compaction temperatures, roller settings, everything like that. And that's huge. That right there is all your compactive effort. So with asphalt, we're looking for a certain density. This compaction effort is super critical information. DPS is kind of giving us the final surface density. And so really quickly using Beta, we can look at this and say, okay, DPS data shows low density. Let me go back to my other construction data and see why it's low. And this, these troubleshooting capabilities are really powerful. Future improvements, George talked about this today. So this year, the big thing happening right now is Beta is moving from a desktop version to a web-based version. So that's all ongoing. And then we're also incorporating all the MDMS information. So Beta Center is the future. MDMS, we've been piloting since last year. We're really ramping that up this year. I think there's 6 DOTs and a whole bunch of projects where we're going to be looking at all the MDMS data. And then by 2027, we should have that and all of the desktop information kind of migrated up to Beta Center. So pretty exciting stuff. I don't think we have time for questions at this moment.
Wait till the end.
We'll wait till the end. And so I'm going to give one more plug for our conference though. So it might not be the last time you see this, but definitely plan on meeting us in Louisville. It's going to be a great conference. We'll be going all into ICT. Thank you.
Okay, bear with us for a second here. I'm going to bring up a little Mentimeter question poll to kind of get some audience participation going on. Okay, so please scan the QR code or go to mentee.com, and there is a code for this group. It's 92590465. Oh, we're getting some folks weighing in here. So the first question was, well, the text started getting really small, so I had to cut off my list, but I was trying to get a broad range of intelligent construction technologies and try and get a general sense of where we are at nationwide. Well, I think we're starting to see a trend, so I think we got some growth opportunities, which is great since we're here. Which is why we have these pooled funds, and we'll be hopefully increasing this involvement and engagement. I think we'll go ahead and pause since that took me an extra minute or two. We're going to move over to a manufacturer's perspective of intelligent construction technologies, and we're going to have Todd Mansell with Caterpillar presentation. Oh, sorry, one more quick note. We will do another question after the next speaker, so keep your phones handy, and we'll move to the next question.
All right, good morning, everyone. So we're going to do a little manufacturer's perspective on some of these technologies that Amanda just introduced us to. I think I'm more here if people have questions after, but I'll go through some of them. Amanda explained them quite well. So when we look at dielectric profiling from a manufacturer's perspective, we've had the sensor, the push cart version, if you will, and now we're moving toward roller mounted or real-time measurement of compaction on the rollers themselves. So you can see Tom's got one that's commercially available now. I think it's safe to say there's some others that'll be pretty close behind in that space. And then down in the middle there, you see our good friend Bryce with the push cart single sensor measuring using a GSSI sensor, checking the profile, density profile across the width of the map in that case there in North Dakota. So that's kind of availability wise. When we look at that, the sensors again are getting more and more available. There's still a lot of limitations and information going on, how far the depth of the sensor reads into the pavement, things like that. So there are definitely some things, and that goes back to Amanda's chart on adoption, how fast, where they are in that whole process. As far as training in that, there's a lot of the training goes through the manufacturer, if it's just the equipment setup itself. When it comes to it's still not, as far as dielectric goes, it's still not, I don't think, very, Matt may have more to say on this. I don't know that it's very well defined from a supplier's perspective. It's a little bit of figuring it out as you go on the dielectric profiling part of it. And I think that's really about all I have on that. And then when we look at MDMS, so I say e-ticketing or MDMS to me is e-ticketing on steroids. You've got a bunch of it. You've got e-ticket information, but you've got a lot of additional information as well, mixed properties and all that stuff. So there's several manufacturers or suppliers of these e-ticketing softwares, a lot of different amounts of information that you can get depending on the vendor. But I would say they're fairly readily available. The back office part, that may be vendor specific, but again, go into data. And we can bring that information into a common platform. Yeah, and I think the features, again, e-ticketing is kind of the basic feature, and then there's a lot of additional features depending on the manufacturer or the supplier. Intelligent compaction rollers, I think a lot of us are familiar with those. There's a double drum asphalt roller, same basic technology except for the temperature sensors when it comes to a single drum or soil roller. So that's the hardware, but the basic thing there, you've got geospatial information, so positioning, temperature on the asphalt, accelerometer is the conventional, again, now starting to move into having dielectric sensors on there to correlate with density. So that's the way out. It's a pretty mature technology as far as equipment suppliers go. So readily available, lots of training from the equipment suppliers on the actual installation and use. And then again, in this world, importing all that data into beta software and the beta training, of course, that's been going through largely through Transtec. I guess the next thing I was just going to say, what's next? Truly intelligent compaction, and we've had this debate for, or not, maybe not debate, but just clarification for a lot of years is we've called it intelligent compaction, but it really doesn't do anything. It provides information. The thing where the future is going is now getting into adaptive systems. So now we've got this information, whether we're measuring density and getting a better correlation with it than we did with the accelerometer, and now it's machine control beyond that based on the inputs from the accelerometer density and temperature info. Then pavement thermal profiling, again, from the manufacturer's perspective, pretty mature, readily available, easy to set up and use, if you will. So there's not a lot of surprises there. I just wanted to show a couple slides on where, again, Matt may talk more of this, but a lot of the benefits, and Anna mentioned a few of them, but when we get into the thermal mapping, it's temperature for uniformity, you know, theoretically translates to better compaction or more uniform compaction, but it also translates into, man mentioned segregation. So you look at this image, you can see a segregated one on the right side, the picture, but you can see that happening in the thermal images. I can look at paver hoppers, running hoppers low, speed of the conveyors aren't set right, sonic feed sensors aren't aimed properly for the feed system on the paver. So there's a lot of operational things, all quality, that we can pull out or extract from this thermal information. And I think looking at it, I would, and it's not from a money perspective, it's from a quality perspective, I would like to see more contractors adopting this technology where it's not because it's specified, but because of all the value. And going back to my QC days and 20 years ago, I wish we had this, you know, because it just has so many things you can look at quality wise. And then the differential milling from a contractor's perspective or OEM's perspective, pretty mature, I think, technology. You know, we understand how to set it up, put it on the machine, and get the outputs. I think right now where it's progressing more is actually in the process, not so much the equipment. So I think the equipment, I know the equipment's there. It's just getting that whole process flow, creating that, getting the scan, getting the design file, having that file loaded back onto the machine. So the whole process part of it's where I think we need to get a little smoother. No pun intended. And I think basically Amanda covered this, and I kind of already talked about it. But the equipment itself, mature as far as AMG and all that goes. I think it's just the understanding and learning the process, whether it's 3D milling, differential milling, or somewhere in between. So, That's all I have. Any questions, or we can save those?
If there's anything quick, from manufacturer here.
Or I'll be around, so.
We'll also have a little time at the end, hopefully. Perfect, yeah, just a slide. Okay, so if you still have your phone out, it still should be the same group. And now there is a new question available. Please take a minute to jump back in the Mentimeter. This doesn't have to be for all technologies, but you know, anyways, a technology that you're familiar with, is there some artificial intelligence being adopted or deployed with any of the ICT technologies you're familiar with?
Do you move to the next one? Or, oh, okay.
Okay. So I think, again, some room for opportunity for manufacturers to implement or better market their abilities. But with that, we're going to move to Matt Oman. He's the Vice President of Paving and Engineering Technology at Mathy Construction, and he will be giving us a contractor perspective of intelligent construction technology.
Thank you. I'm gonna stand back here. We can talk later. I'll tell you all about it, but I'm just gonna stand for a while. Congrats to John and George, our award winners today. So I'm gonna run through this quick. Some of these are ideas from our staff. Some is my thoughts. And then I actually reached out, and we'll see that in a second, to get more of a broader base for contractors. And then at the end, some questions. So some of these, so basically, as we're going through this, our equipment, you know, it does require a lot of lead time to get this equipment, whether that's new parts or new equipment. So you just have to be prepared for that. And then there are delays, which you have to kind of plan for, which can be deducts if you do need repairs and things like that, if it goes down. So the training and support, we do a combination just with the, from the vendors. And so again, this is IC, thermal, and MDMS. We'll do a combination with the vendors and our own in-house. But we do have a wide support network, so we can get this, we get pretty good support on this. Benefits, we get a lot of real-time benefits from this, the quality checks, especially the thermal, which is right on the back of the screen. We do get a lot of large data amounts, and you can kind of tie everything together, which has been mentioned. The MDMS does have the ability to kind of reduce some of the back end in the office, whether it's payroll or things like that, where that will be things that we can leverage. And then, of course, the safety, pretty much particularly with the MDMS and the tickets, not having people out that are, you know, not always out there. So that's a big benefit. Some of the unintended consequences, these were kind of some ideas, these topics were that Mike suggested. So that's where they came from. So there's a reduction in production. So we will have slower rates with some of these failures. Now, the other thing we noticed is that you do have to move equipment around more often, and because your whole fleet is not instrumented, so you have to hop from job to job. When things go down, we have to have kind of an immediate response, whether it's our own technical person or from our vendors. And then there's extra costs if you try to build in redundancy to not have to, when there are malfunctions. Some success stories with this, we do have changed our operations from what we've learned, which makes a lot of sense. We added an MTV. I don't know, I later will call it widespread use of it, but it's maybe just us. But I do know that MTVs have been used more, and this is really to achieve the thermal. And then there's better quality training opportunities once we have this stuff. So these are my thoughts on the DPS. We bought one in 2020, and I've been pretty much our main user of it. So this is my ideas on this, and this is how we kind of use it. So really, to try to minimize data management and any post-processing requirements would be the best benefit from this. And what I mean is use any on-screen reporting and then just kind of move on. When you have to do the data management, you dump this out. There's a lot of processing, which is fun for me, but practically moving forward, that's probably not the way to do it. So just on-screen reporting and then get out of there. I like to say, just leveraging the relative measurements in this, which kind of, we've done a lot of the testing with the pooled fund. And the absolute values where you're validating, calibrating, all of that they work really well, but for us, from a time standpoint, just relative. If I just measured this whole floor here, there was a parking lot and I could see that this area is different than that, that would teach us a lot. So I don't need to know what this is perfectly versus that. So we just like to think of relative, and then again, we get out of there. It is a very great investigative and documentation tool. We'll use it, for instance, on commercial paving on a parking lot where we may go out when we're done. We'll collect an entire area and we'll learn from it and then use that as a training tool moving forward to show that here's what happened with these operators, maybe the way they paved it, and we can see that. And then again, there's a lot of data analysis opportunities. So this says contractor perspective. So I was like, well, what if I can get more contractors? So I talked with HAPA last week and they sent a survey out. And so we had under a week to do it, but we got 7 responses. So these next few slides are from 7 people. I don't know who they are, but we got 7 responders. So the questions are pretty generic, but we just wanted to have easy questions that would be, people couldn't have to come up with their, they may have multiple answers. This was easy. So which ICT tool do you feel provides the best value to your production or quality? And so DPS didn't have any because it's relatively new. IC was 1, thermal was 2, and then MDMS e-ticketing was 4. So pretty much from this small sample, MDMS provides the best benefit for this, which probably explains why that's the full scale implementation now across concrete and aggregate, and it's moving forward everywhere. So which do you feel is the biggest hurdle to implementation? And this was kind of sprinkled around, but like George said, the training was the one that seems to be the biggest in terms of hurdles to implement this. Now this one was a little surprising. So is new equipment or are repair parts quickly available when you need them during a project? Because like I said, there's downtime, and this could be wires. I mean, there's countless things that are out in the elements and things break down, whether it's just a physical connection. And so no, so basically, we need to have these things on hand. This isn't having a whole new system ready. This is just parts and things like that. So, but that was pretty eye-opening. And then this was kind of sprinkled again. Do you get the training and support you need from the vendors? It was kind of yes or no. And I'm guessing that probably depends on what you're talking about. If it's IC or thermal, there may be different pieces to this. We could have had more follow-up questions, but essentially yes or no. And then are you able to retain your staff? And because it is a lot of these, especially the Veda end, there's a lot of specialty analysis you have to do. And 5 of the 7 said that yes, they do. So I know we've had our same one the whole time, so it can make a difference. So now I'm going to ask some questions back, and I say MnDOT in here, but it could be any DOT who's been doing these. So this is a chart that Mike sent, and it just shows the red is IC, red's thermal, IC is the gray, and MDMS is the blue. So you can see I drew in these little lines as just general trends. And I was kind of curious if that is really the trends of where we're heading, or if it's just like a blip in the data. But this is talking about the number of projects. So it's not lane miles or tons or anything like that. So it looks like MDMS is really trending up. And as I said, that's being implemented everywhere. So I'm guessing that one's just going to keep shooting up. The IC and thermal, I was wondering if this is just fewer jobs because multiple jobs were coupled together and now it's one project and it would show up as one. If there's just, jobs are not requiring it, or if it's really just less paving. And I believe talking with Rebecca, it's really just kind of less projects is what's been happening. So here's my walked away. So basically is MnDOT getting better data, better density from the IC and from thermal? And if it is, could we compare densities achieved or like densities per ton or percent density possible? Is that changed from before and after implementation? And if it is, it'd be really interesting to know that. Same thing, has ride changed, and really particularly with the thermal, because as I said, for us, we used MTVs, which will then lead to less paver stops, which will be smoother pavement. So I'm curious if you could somehow look at incentives before and after to see if that's changed. And then we all know we should get better performance if density and ride are better, but it's not what we're seeing. So it's maybe too early to tell on some of these, But if not, we could maybe revise those timing structures and then incorporate that into some of our analysis and programs. So that's it for me. So I'm around all day. We can talk all about my stuff.
Thank you. Well, good thing we do have some agency perspectives coming up here. So since there were a couple questions in there in the slides. Yep, next slide. So back to the Mentimeter, please. New question. Just take a moment to enter response. And I think we're starting to level up. So some good coordination going on, but some potential partnering opportunities for some states to help push intelligent construction technologies. We are going to move to an agency perspective for intelligent construction technologies, and we're going to move to Curt Dunn. He's highway materials engineer in the Grand Forks Division District of North Dakota Department of Transportation.
So I'm going to talk a little bit about what the experience North Dakota's had here in the last few years. So gonna maybe just restrict it to 4 technologies today, and although we're doing experimenting with more. So paper mounted thermal profile, dielectric profile system, intelligent compaction, and ETA. So I say for the intelligent compaction and paper mounted thermal profile is we've been requiring that on projects for probably 10 years now. And Rebecca and her team at Advanced Materials and Technology pretty much provided us with the blueprint when we first started to move forward. We had some pilot projects where we basically, change ordered the special provisions that Minnesota already developed in their program. And to this day, we're still using those pretty much word for word. And as far as incentives and disincentives, though, we don't have that. We had the first couple of years for paper mounted thermal profile, but we got rid of that. So we wish we could still have it. Anyway, so as far as the dielectric profile system, we had a peers change around, I think it was 2019, between Minnesota and North Dakota, and Kyle actually brought the push unit over to demonstrate in North Dakota. We actually had a project going on at the time in North Dakota where we actually got some data. So that was a really success. I remember being at that one. And so that pretty much led us to get into the pool fund there, and also to purchase our own unit. And eventually we push unit, and then we eventually got one that works out in the back of the SUV there. So every year, Materials and Research has went out and collected data on active projects. And I always like it when they come to, when John Stork comes out and collects on Grand Forks projects, because then I can take the data and put it in the data and compare it with the other things as well. So as far as I think Materials and Research has seen a good correlation between the cores that we take, and as far as not maybe no immediate plans at the moment, but the ultimate goal, I think, is to at least reduce the core and maybe even replace it at some time, using the DPSS and acceptance tools. So as far as e-ticketing, say in the last couple of years, we've been requiring it on pretty much all the asphalt projects. Right now, we're just working, we work with a vendor, contracted with a vendor for managing tickets, so just getting source data at the time. And we'll talk a little bit more about that in a little bit, but so. Okay, benefits. So I'm gonna borrow a statement I think I heard from Curt one time in a presentation. We know a lot more about our pavements than we ever did before. And we have history of, pretty much every square foot of pavement. So we know a lot of things we used to. And as far as comparison, with spot testing and things like that, it's so overwhelmingly superior to that, I think. You get 100% compaction, or I should say coverage. And, you can get the whole picture pretty easy. You can collect the data a lot faster, a lot safer. And you have, it's non-destructive. And, you can see you can see things out there that you can't see with your eye. And that's a really big one too. So, over the past several years, North Dakota's tried to, take all that data and look at the post-analysis of data. And then with the goal of educating the industry and our engineers and inspectors out of the project to look at things, what to be aware of out there. And I think it's working pretty well. We try to, go to the meetings, the user group meetings, conferences, things like that. So, just in the area of paper stops, as we were talking about earlier, how it really does affect the ride. And you can see the NRRA is spiking up in all of those areas, especially the bigger, more duration paper stops, as well as density too. You got your density over there to the DPS data to the right, and you can take a look at that and say, well, why is that not working out for us? For one thing, there's probably, you can filter it down in the data where you can actually get the effective passes, where the passes that are going to do some good for you. And, well, what's causing that? Well, it's basically that paper stuff there. So, but, so I think we actually have, it was uncommon, or I should say it wasn't uncommon to, see maybe if the paver was paving 10 hours a day, we probably had 44 hours a day that it was stopped. But I think we're actually seeing some lesser durations of paver stops going on now. So here's another benefit, and this kind of goes back to being able to not see something while you're paving with you and I, but so little background here, we have a specification in our North Dakota that has a specification that we just require an ordinary compaction or a method spec on our shoulders. You don't have to measure density. And so this 2.5 foot shoulder here, it really doesn't need the measured density. So John Stork was out collecting data on this roadway. He was collecting data on the whole map there. And I was standing there and he came by and he says, the dielectric values are a lot less in the shoulder area. And so, we looked at the data there and that's kind of how it showed up. And one of the reasons for that was there was less passes. And you can also see the density differences there too. So, maybe 6-7% differences in density. So this prompted a little curiosity. We started to do some information coring. We come up with that. And we saw that a few other projects as well. So actually from that, we started to look at, requiring compaction on shoulders in some of the major projects, like interstate projects where there's asphalt shoulders. So that was a positive. Another thing is that I think with all the knowledge we've learned from all the post analysis that we're North Dakota's moving toward specifications that, not only look at promote good density, but also no standard deviation, uniformity and things like that. So So in this case, this PWL, percent of the limits, excuse me, is starting to look a little bit, we're having a few more projects in it. You can see how the averages are kind of, contractor kind of likes to, get the averages about the middle of the upper and lower limits. Which actually helps. You can see those scores here, how, there's not much variability there, maybe 1% or a little bit, So, and here's just from a PWL project, it's just from a thermal camera from the back of a paper, how uniform those temperatures are. So that's a really good thing to see. As far as future and things like that, as I mentioned earlier, I like to look at the post analysis of things, but it's easy for me to forget that it's actually the contractor. The primary reason for all of these technologies is really to get the contractor to use them. Anyway, so I guess I always ask my question, is the contractor getting the full benefit out of this, out of these technologies? And, I think in North Dakota, we see a little hesitancy sometimes to use them. And, what is it, ease of use, for instance? So I think that a lot of cases, they would use it if it was, a little faster. I think that's why you see the nuclear density gauge as being so popular yet. Out there, you can see all the technologies around it, but they're still using that. And it's basically because it's fast and easy. So I think, it'd be nice if we could move toward, using, trying to make it faster and easier, because we have great technologies here. It's just a matter of getting it to the contract. And just was mentioned earlier, that e-ticketing is probably, of all the technologies, probably taken on the fastest, because even before we started requiring it, the contractors were using it for to manage their fleet up there. So it really is taking off, and I don't know if it's something in their software or what, but they certainly are using it. So I guess with all of this, wouldn't it be neat if you could pick up, bring up, say, a time filter where you could bring up the last 5 minutes of paving with all the technologies on in one screen? That would be pretty neat. I think the contractors would really go for that. But I think, I guess our hope is that, and I think it's really becoming reality now, is that the beta software is going, after it becomes web-based, it's going to go a long way to solve these problems, I think. So the last slide I have is we have the opportunity this year to experiment with on a pilot program with the material delivery management system and data center. We're very grateful for that, and we're going to have another project that also has our regular way that we're doing e-ticketing. So this is more for information at the time, but we've been working with Rebecca and Brian, and I think it's going to take off here in June. So hopefully have some good information. So, and that's all I have.
Before we get our other agency perspective, we're gonna do one more poll question. See if everyone's awake. New question is up. Please jump back on your phone. It's starting to level out, but some good partnering going on, looks like.
So our next agency's perspective will be from Deepak Maskey. He's a senior transportation engineer for the California Department of Transportation. Thank you. Good morning.
I'm here to cover about Caltrans perspective from research to implementation. What are the issues and why it is not being implemented in duties in our projects. And here we have two pavement offices. I'm from Concrete Pavement, and my partner there, Raghu, raise your hand. He's from Asphalt. So we both are here from California. So those are our offices. This is the major field we do that. The research innovation, we give technical support and develop and update any specification and guidelines. And we partner with the industries. There is a pavement and material partnering committee. I'll come that in the later on. And we do life cycle assessment and life cycle cost analysis too. So those are the major activities generally we do. And whenever it comes about intelligent construction technology, because it's not only this technology, anything when you need to implement, there are the major things comes in the picture. Research is done, either testing is done properly in California aspect. What are the limitations of all those technologies? And are those technologies being field verified? Not about only equipment, total output, field verified, and output is really working for us. Is it really working for us better than what we have? And is the specification or everything is street ready, means easy to use? We don't have to hurdle here and there, because once we put in a spec, we have to worry about all those issues during construction we come up. Just like earlier it was mentioned, if there is some change, something happens, the equipment whole thing is delayed. So there are so many things we have to look at it. And the best part is always we need full-fledged complete guidelines and specification. These are the main important part. Once we have everything, then it is ready to go. So what we need to do? So those are the things we need to do. We have to look at it. Design and construction guidelines. With all the districts, we have 12 districts. They are the main stakeholders. They start and do and use any technology or any methods. So we have to train them and support them. And we have to look at it impact, not only Caltrans, we have to look impacts to our industries too. And also the big part is the cost. How is it going to happen? How is it going to impact? And as I already mentioned, spec has to be very perfect. We use word street ready in California. So once spec is done, then that should work perfect without any issues. That is what we are supposed to do right now. And again, this technology, are we using for quality assurance or quality control? They're the big things. Because generally, if you look at it, most of the technologies are used for QC, mostly construction contractor side, not agency side. Because agency, if you do assurance for the payment, anything, we do the final. Can we rely on those? So those are so many questions are there. And to use any of those technologies, we need standard specifications. And standard specification, the way we develop in California, we have a committee, it is called Pavement and Material Partnering Committee. So it is partnered with industries. So there are 50% members are from industries, 50% from Caltrans. And we have 3 levels. If you look at it, it is a partnering in agency. We have Federal Highways and Caltrans. We have mostly our three offices. Our office, headquarter construction, METS, which are testing, and districts, and industries. So industry covers big areas. Contractor, consultant, producers, huge. It's a big area. And for example, it is a Calcima, California, the Calcima. Yes, those are the industries right now. They are involved. You guys already know all those, I guess. Southwest Concrete Pavement Association, California Nevada Cement Association, California Asphalt Pavement Association, and California, this Industrial Concrete and Industrial Material Association, something Construction Industrial and Material Association. It's a huge organization. So those are all are involved. All our umbrellas in our umbrella organizations, so they are involved. And this is a kind of, now I'll go a little bit in detail how we develop specifications. So this is the committee, this is the structure, just general view. If you look at it, the sponsors are our deputy directors, then division chiefs are steering committees, those are only Caltrans. And below that, from executive level and below, industries are involved. In the executive committee level, industries are involved. And then below that, there is an asphalt group, asphalt task group, and concrete task group. In asphalt task group, again, industry is involved, and even concrete task group, there is industry involved. And below that is sub-task group. Every sub-task group has 8 members, 4 from Caltrans, 4 from industries. So industry, they choose and send their names, and we make this committee, sub-task group committees. So if you look at it, there are three sub-task group under each concrete type of pavement, like a. So anything. So this is just I'm trying to give you overview. This is not a legislature, a kind of legislature. Okay, we deal every day. So what we do under the sub-task group, we develop items. What items need to be developed? What specification need? Do we need new specification, or do we have to change or update any specifications? So those are first we develop our bin list, our wish list. So we call bin list. So from bin list, we choose which item to develop because we don't have resources. Generally, we choose 2 or 1, 2 or 3, not more than that, because it's a lot of work. It's like a project. And then any topics, any specification, if we have a good information, if the change is obvious, it's not going to impact that much, and we don't need that much resources or time, then we just do through decision document, which is just write a justification and make a decision document and get approved. And decision document is get approved by ATZ level. Or then after that, if you don't have, if it not is simple, if it is a little bit, we have to do a little more, then we develop a scoping document. And after developing a scoping document, then we work on, then we call work product. Then work product becomes a kind of project. Then that work product's been worked, executed, and then we develop any specifications or guidelines. So this is the standard process. And this is the who approves what that earlier I mentioned. So it goes up to executive committee level. They are the one final to say go or no go, or they may ask questions, so many things. So those are the things, the way we use. So most of all the cleaning, all the details, research, mostly we do at work product level, the group. So that committee work group works on it. Generally work product group will have subject matter experts from industries and from Caltrans, and they work together and they produce either specification or do recommendation for any report, and that goes all the way and get approved. So this is the way how it gets approved. And generally, it doesn't go in one way. There are so many questions, so many hurdles. There will be, so generally they will say, is that still ready? Big questions. And they will come about the cost. They will come out, does this technology work for us? And how what California will get benefit about efficiency, what we get. So that is the major part. What this deliverable, what we get. That will be the major question from top level, each level. And we have to justify them, we have to tell them, we have to give presentation. And if they are happy, we get blessed, then we work on. Once it is done, then the specification goes in internal process for publication. That takes another time too. So it's not like easy when any intelligent technology, this construction technology comes in the picture, So there are so many questions from starting to all the way to use. So we have to think about it. And also when a specification is done, so they have a label. If we are not happy, we need more information, or we have to do on project level. So it becomes NSSP. We use in project level. If we need more information, if we want to see how it works, then we do pilot and get the data and then improve our specification. And if we are a little confident and it is only required in certain time or certain projects or for certain location, then we make SSP, special provision, that could be added to the standard. And we are confident if it works, everybody is happy and it works perfect, there will be no issue, then only it goes to standard specification, which by default, that will be standard for all the projects. All right, so I'm trying to give you the flavor, I mean, from this technology and to use real world in use in field in California. So those are the processes we have to go through. It's not easy. So I'm trying to give you a flavor. The question being asked like why it is not being used, right? And again, the earlier Amanda showed where the maturedness and what is the limitation. Earlier Amanda's chart, that was really good presentation. So those are the things we have to look at it, because from agency perspective, we have to see always, and also we work with the stakeholders. So stakeholders is not only one group. There are so many groups. Think about it, industries means not only one industry, right? Supplier, contractors, subcontractor, manufacturers, so many stakeholders. Same thing in the district. We have 12 districts. 12 district has this, they have a different requirements. So some remote areas, you cannot ask them to use this technology, right? You need support. So we have to look at it, everything before we put in the standard spec to implement it. Thank you.
Okay, I think we got a couple more Menti questions. Slide. Or at least one more question. That might be it, but.
I think that's it. The next thing is presentation.
Okay, some good responses there. I guess I'd like to, we do still have a couple more minutes, at least on the agenda before lunch technically starts. I guess I'll throw out a couple of thoughts, with the presentations, some of the questions that were posed, and maybe that'll get other folks to get the questions, but, I think a lot of effort is put towards these intelligent construction technologies, proving a number of existing best management practices. There's a lot of after the fact things that happen. It's something happened. We're trying to figure out what happened. These technologies sometimes tell us more of the story and we can pin it down. And I feel like the majority of the time, again, it's already we reach out to someone like John Garrity and he says, well, okay, well, this is what they're supposed to be doing. Maybe that didn't happen in this instance or, you know, that occasion or this part of the process. And we take that information and we try and provide that back to industry, get that information to the contractor, to the agency project staff, try and get that feedback. But there is a little bit of a delay. A lot of these technologies are trying to close that gap of information, time to process, get the feedback and get it back to the people that can use that to make a change or a difference out in the field. So, and I think I guess a couple more comments about the technologies themselves. On the agency side, you see there's even at MnDOT, there's a lot of process that takes to get some of these technologies on these projects. I don't think the agency's trying to solve all the problems out there. I think there's a number of opportunities for the manufacturers to develop a secret sauce, so to speak, or something to bring value to the contractor, which on the agency side, we really want to encourage, we want these technologies to be out there. But we do hope that the contractor uses these technologies and then can react for themselves. Ideally, so I would comment.
Yeah, that was just something I thought I'd add. You know, we've seen a lot of these technologies in different, Curt showed an example, and showed earlier, we're looking at pass count mapping, we're looking at thermal behind the paver. So we look at very, very seldom, in my experience, is like one thing that's causing a major problem in the field. Like if it was just one thing I was doing, if I was skipping one roller pass, but I had uniform temperatures and right had material on the paver and all that good stuff, I probably still have good density. So where I'm going with this is, I think if we can bring those technologies and do what we were showing in the beta, bring them all together, that's where you really paint the full picture and get the value. And then the other thing, and Matt came to it, and I know from my background is if you can get this, you mentioned it, if you get this information quickly, that's really key. That's kind of on us as a manufacturer to that better.
Yeah, and hopefully, bridge some of the skills gap. There's, it's been great talking and working with Matt for a number of years. But some of these contractors do have turnover. Some of the people that are actually doing the work, there's turnover, there's new people, there's training, and giving them tools to hopefully, do a better job. Oh, no, we're done. Perfect.
I think, Matt, before ask a good question, how do we see how this ICT technology, how are they including our payments in the market? I guess my question with that is that any thought or including or bringing in other performance measures like IRI or something to data so that people can see how this is impacting
But yeah, this question was, do we plan on adding other features like smoothness that George was talking about this morning to the beta, and that is on our wish list. So we'll continue to add different elements to it along with weather station stuff. AMG, there's stuff related to AMG we want to get added as well. So the sky's the limit. We've created the software as part of this pool fund to allow for growth intentionally, because we know things are going to continue to change over time, right? And so we have the ability to do all these add-ons and stuff. So, but yes, we do want to be able to overlay IRI on top of thermal with respect to the paper slots that Curt was showing.
Comments, questions? I saw Glenn first, so.
It's like interesting session, and Matt mentioned this in his talk. He talked about parking lots. And I know in the concrete industry, data centers are going in, Amazons are building, or you name it, a lot of these private fire things that aren't necessarily required by agencies. I wonder if we're getting anything from them. It says you guys don't know it.
Private. We're really doing it to kind of learn about ourselves, making it doing the best we can. So if we see something, maybe look at the data and you find, oh, there's a spot that just looks different, we'll talk to the foreman or so you learn, well, maybe you figure out the different stages out of this area. You just learn from it, and maybe there's better ways that they could have the project and it out better. And so we use it as a kind of like You guys get it right. Thanks.
I'm not supposed to say that, but there are hundreds of data centers being built in this country. And Meta, Google, and they wanted to be done yesterday. So they're accelerating the construction. And with the conventional way of using spot test or moving this fast pace is impossible. So all these high-tech companies are looking for those technologies we talked about today to accelerate the process by using better full coverage, faster real-time information. To Todd's point, the more information they can get early, they can get the issue sorted out and accelerate the construction. So the time is not on their side right now for the hundreds of data centers being built in this country, and they may very, very likely to jump into those technologies.
Other thoughts, comments, questions? Oh, well,
I was just curious, was, I don't know if this is for Rebecca, is MnDOT still, are you still doing your scorecard? Because I thought that was great. Anyhow, just a question.
I think it just, well, because that was part of my responsibility, but it just went out a week or two ago, so. Yeah, it is out there, so Matt got his, he asked about his results, so.
I think it's great.
So I guess just for information that, for MnDOT, since we have a number of IC, PFTP, MDMS jobs, we have a report card that we've been putting out for a number of years. So there is some tracking of history on how things are going, and also so we can help talk to contractors and see if they want to move in a different direction, I guess. Other thoughts, comments, questions? Everyone's hungry.
Definitely notice it over time. In the report cards, you can look at it. I think they're available. You can find them and download it and get it. They're all coded, so you can't tell which contract is which. That's where we have to be coded with these guys. But if you look at these, you can see there's definitely been improvement over time as these were developed. Beginning, obviously, no one knows what they're doing and they're learning. And you keep going, but they've definitely all improved over time. Whether that's showing performance, that's what we need to figure out next.
Thanks. Yeah, it is on our website. So if you are ever curious, reach out to me. You can see how at least MnDOT's doing or has been doing. Anything else?